Assalamu alaikum, I'm Mahmoud Sameh, great and see, and inshallah in this video I'll be explaining and answering questions about stoichiometry as you can see. So first of all, there are some background information that you need to know before starting in this video. So first of all, stoichiometry is dealing with equations quantitatively on the molar level, not the molecular level, and you're gonna understand this more while we answer the questions about stoichiometry. And then you should know what is the limiting and excess reagents, and you should know how to balance a chemical equation, and what is the mole ratio and how to get it, and how to to identify it from the chemical formula, and what is the lovely conversion triangle, which is this. It's mainly to convert from moles to grams and from grams to moles. Also, this this is stoichiometry. So uh, don't be too scared. Don't be too scared. We're not gonna use all of it. We're gonna use this part only. It's still scary. I know. It's still terrifying. Not scary. It's still shocking. So these are yeah. Let us explain it after the first question, so you can understand it in a better way. Let's hop into the first question. So the first question gives you an equation. It's not always balanced. This one is balanced, but it's not always balanced. So you should check if it's balanced or not. So it's ammonia reacting with carbon dioxide gives you urea and water. So in one process, 637.2 grams of NH3 are treated with 1,142 of CO2. So these are the givens, and this means 637.2 means that we have 637.2 grams of NH3, and we have 1,142 grams of CO2. So the first question is, which of the two reactants is the limiting reagent? So for getting the limiting reagent, we're going to pass through these steps. So the first thing is to convert the 637.2 from grams into moles. The 637.2, by the way, is the amount that's given from the by the ammonia. So we have 632, as we said, 637.2 grams of ammonia, and we should convert this number from grams into moles. So let's do it. So we have 637.2. And for converting it into moles, we should look at our lovely triangle, which has all the conversions that we will need from mass to moles, and from moles to molar mass and grams and all of these stuff. So we need to convert from grams into moles. So for converting from grams into moles, we should make the mass over the molar mass of the compound to get the moles. So that's going to be 363, 637.2 over the molar mass of the ammonia, which because the 632 is for the ammonia, so the molar mass of the ammonia is 17.03. That's gonna give us 34. Sorry, that's gonna give us 37, uh, 37.4. That will be moles of ammonia, of NH3. Okay. So now the next step is to convert from moles of the reactant to moles of NH2 urea, to moles of the to moles of urea. So for doing this, we're gonna look at the equation, and we're gonna guess from it the mole ratio. So the mole ratio here is 1 to 2. The mole ratio is basically the number that is here. Here there's nothing, there's nothing, so that's 1, and here there is 2, so that's 2. Here there is nothing, so that's 1, and here there is nothing, so that's 1. So here we have 1, and here we have 2. So the mole ratio will be 1 to 2. we always write most of the time we write the product on top, so we can eliminate, because this is two moles of NH3, so we can eliminate this by this, and the one that's remaining is moles of urea. I'm not gonna write it because it's too long. So this will be 37.4 times 1 over 2, which is, I write it here, it is 18.7. And it's going to be in moles of urea. I'm going to write it this time. That's it. That's not it. That's not it. Still, that's one of the compounds that are given. We still have the other compound. Okay, so now with the second compound, which is the CO2, and it was given that CO2 has 1,000. We have 1,142 grams of CO2. So the first step is convert the grams into moles. So we're going to do the same thing, and here is our lovely triangle. So we will make grams over the molar mass. So that's 1,142 over the molar mass of the CO2, which is 44.01. This will give us 25.95 moles of CO2. So now we're going to convert, the second step is convert from moles of the reactant to moles of the product, which is the urea. So we're going to multiply it by the mole ratio. We're going to look at the ratio uh, of both compounds. So we found that the urea has 1, still as it is, and the carbon dioxide has 1 as well. So it's 1 to 1. We always put the product on top, so that's 1 of the urea. I'm not gonna write it, and 1 CO2. Okay, so that's gonna be 25.95 times 1 over 1, which is 25.95, and that's gonna be in moles of urea. I cannot write with the mouse, like, so hard. Okay, so this is the second the second number that we have. So now we have two numbers. We have the 18.7, which we got from the ammonia, and we have the 25.95, which we got from the carbon dioxide. But now both of them are for the urea. I think I think that I write that urea is spelled like this. I think so. So both of them are for the urea, and both of them are in moles. This is not a division, okay? That's just a line. So now we're gonna identify the limiting and the excess reagent. I underlined both of the limiting and excess. So the limiting is surely the smaller number, which is 18.7, because it will finish faster, or it will be used faster in the equation. And the 25.95 is the excess, because it will remain يعني there are some atoms that will remain at the end if we calculate it by this. So that's the limiting, and the other one is the excess. So now we have answered question A, and this is the limiting reagent, because question A, if you remember, question A asked which of the two reactants is the limiting reagent. So the limiting reagent is the ammonia, is is the 18.7, which is for the ammonia, which is NH3 for the ammonia. So this is the answer for question A. Now let's see question B. It's asking for the mass of the urea formed after the urea, which is after the reaction. So there is one step that we're gonna do, which is this one: convert the limiting reagent from moles to grams. Why the limiting reagent? Because we always do our calculations on the on the lower number. So we don't, yani, if we did it on the excess, the limiting, because it's the smaller one, will not fit our needs. So the limiting reagent was 18.71, and for converting from moles to grams, from moles to grams, we should multiply by the molar mass. So this 18.71 is for the urea. Okay, so we should multiply this 18.71 by the molar mass of the urea, which is 60.06. We got it from the periodic table. And that will be 1124 grams of urea. I actually forgot the formula, so it's urea. I'll write it like this. Now let us get back to this, the mole conversion diagram. So we said that we're using these four steps. And believe me, you're gonna thank God that this is found on our planet for stoichiometry. This is everything. This is like the it's nice. I love it. It's nice. So if you notice that these are the steps that we have made. First of all, we got the givens in grams, which were these, the 637.2 and the 1142. They were in grams, if you noticed. Then we converted them into moles by when we divided it by smaller mass. So we converted it into moles of A of A. So that was grams of A. We converted it into moles of A. If you don't remember that, you can just يعني get it back because this is a video. So you can, yeah. Then we converted from moles of A to moles of B, which was the product. That the A is the reactant and B was the product. When we converted from when we used the mole ratio, when we converted from the ammonia to the urea, remember that when we made it by the mole ratio. Then in question B, if you remember that, we converted from moles into grams to get the amount of urea that was formed. So that's why it's grams of B, because that was urea and that also was urea. We used this in both steps. And when we were making the ammonia one, and when we were making the carbon dioxide one. So we used it in both steps. B for us in this equation was the urea, and A was once the ammonia, and the other time it was the carbon dioxide. So this is life saving. I love it so much. It's like that is what you're going to do.